To our video on slope fields. Slope fields deal with differential equations. So let's talk about them. So you can read right here. Unfortunately, it's impossible to determine all of the differential equations given the formula. So sometimes we don't know what the differential equation is. We can't solve for it. So slope fields help us give some information about it. So like here's some examples of some. I'm just kind of small on your notes. It should be a little bit larger there. Some slope fields. So if you can see right up here, these are the slope fields. These little lines are just little tick marks. And then actually, I'll just zoom in on that part right now. So as you can see, they're just like little tick marks. But then depending on the initial condition, you can draw lines through them like this. So these are all the different functions that this could be given the slope field, just like for this one and this one. Okay, so we will go over how to find slope fields, but let's first talk about what to do when we're given a slope field. Okay, so let's talk about this question right here. Start the camera. There we go. So a direction field for a differential equation is shown. So here's a differential equation. Now that y prime is the same thing as dy dx. All right, this is one that we could solve because you can separate your variables no problem, whereas like this one over here, this one right here says, I'll write it up for you, it says dy over dx equals y minus x squared, whereas we cannot separate those variables. So for what we're learning in this course, we're kind of stuck and cannot solve that differential equation. Doesn't mean it's not solvable, just not in this course. We're going to go over that. So in this one, you could solve it, but hey, let's just go ahead and answer these questions. Sketch the graphs of the solutions that satisfy the initial condition. So like I said, you're going to have different curves based on whatever the initial condition is. So let's start with 0. So at 0, comma 1, and it's kind of hard to see on my paper, but you have tick marks right here that this is 1, this is 2, 3, 4, 5. So at 0, 1, I'm actually right here. And all I'm going to do is I'm going to follow the path right and left of my slope field. So usually the good rule of thumb is to kind of stick in between two of the slope fields and just kind of follow that path in between. So that's what I'm going to do right here. So I'm following that path in between, and then we're good there. And then follow that path in between, and we're about there. So this is my y of 0 equals 1. Okay, I'll do a different color for the next one. So that one was blue. Let's go ahead and do the next one in red. So y of 0 is pi. So pi is like 3.14, which is going to be about right here. If you notice, this is just a straight line going across. So, well, I'm going to do the same thing. And this is y of 0 equals pi. And I'll do the last one in green. So y of 0 is 5, which is right here. Again, you're going to want to stay kind of in between your paths here. It's almost going to mirror the blue one, depending on how good and accurate of a drawer I am. So this was y of 0 equals 5. So those are the different possible functions, what they would look like if you would just solve the differential equation given those initial conditions. And then it says to find all equilibrium solutions. Equilibrium solutions mean when the slope equals 0. So we kind of already drew one. The red line is one that equals 0. So essentially, this is going to equal 0. Well, you can even look right into here as well. Whenever we plug in what for y, if we plug in a pi for y, or a 0 in for y, or a 2 pi, or a 3 pi, doesn't really matter. So this equilibrium solution is going to be when y equals pi times n. And just is going to represent integers. So every multiple of pi, if you plug it in, is going to give you equilibrium solutions. Okay, so the big thing here is just to understand what that means. Equilibrium solution is when the slope is 0. All right, so now we're going to get into drawing these. Okay, so now on AP, they don't ever give you this many. This looks like this is what 1, 2, 3, 4, 5, 6, 7, 5. So there's like 35 different dots. They'll usually give you like 12 dots to draw on. So they'll give you something like this. They'll give you a differential equation, and they'll tell you to draw the slope field. So that's what we're going to do is practice drawing these slope fields. Best way to do it is to make a chart, an X and Y chart. And then I also advise that you don't do this 35 times. You do this until you can find a pattern. So I'm going to start with, usually I start with 0, 0. So at the point 0, 0, so I know what line I'm drawing. If I plug in a 0, 0, I'm going to get a slope of -1. So I'm going to try to draw my best slope of -1. I'll do that in a different color so that you can see it better. Okay, so that's 0, 0. We'll just plug in another point. Now, I'm noticing here, does the y really matter? So like at 0, 1, I'm going to get -1. So if I go up 1, I'm also going to get -1. So if you notice, the y does not matter at all. So all of these are -1. Did I need to do all of my chart? No, I just figured out that little pattern. All right, so now let's try when x is 1 and y is 0. Is y going to matter? No, that means I'm supposed to do the same thing all up and down. So when x is 1, I'm going to get 0. So I'm going to just draw a horizontal line through all of these at 1, again, because the y does not matter for this problem. And then I can do a 2. When I do a 2, 0 or 2, whatever, it doesn't matter. I'm going to get a 1. I'll draw that in a second. When I do a 3, 0, I'm going to get a 2. So you can kind of see what's going to happen here. So at 2, I'm going to get 1. All right. And now at 3, I'm going to get a slope of 2. Now this is where nobody's going to get like a protractor out and measure what your angle is. You just need to make the 2 steeper than the 1. Okay? So just make it a little bit steeper like that. That's steeper than 1. And you're good to go. Careful not to make it too steep, because you make it too steep and you need to go, let's say that you get like 3 as another one. If you go too steep here, you need to give yourself wiggle room so you can go steeper just in case. So as you can kind of see here, if I just do one more, as you can kind of see here, it's going to go -1, 0, 1, 2, and it's actually going to do the exact same idea. I'm going to go back here. So if I do -1, 0, I'm going to get -2, and then it's going to get steeper and steeper as I go. So I'm just going to be careful not to go too steep on me here. Trying to match up those a little bit. Give me some wiggle room with the steepness. So this is just a little bit steeper than that. Right? It's not perfect. I mean, I'm sure someone look at that and goes, oh, those are both the same, but you can kind of see that in general, these are all just a little bit steeper. And then these are, I know this is the steepest, so I'm going to kind of almost draw a horizontal line, but not quite horizontal. So you can kind of see what this looks like. So this is a slope field. So again, you're really focused on how much of a slant you draw based on 1. So is it more, is it less? That's kind of how we do it. All right, so for this next example right here, same idea. Now in this one, I don't see any x's. So that means nothing is going to change horizontally. So there's no x's, so it doesn't matter what my x number is. So let's do 0, 0. So I'm plugging in a 0, 0. My slope is going to be 0. So as long as y is 0, like at 1, 0, it's the same thing. Okay. At 0, 1, I'm going to get 1/2. At 0, 2, I'm going to get 1. And it doesn't matter what x is again, because it's going to be the same thing because there's no x in my differential equation here. If I go 0, -1, I get -1/2. If I go 0, -2, I'm going to get -1. So I'm going to draw all of these right here, and then it's going to be the same as I go out left and right because it does not change based on my x's. So here at 1, I have a 1/2. And here at 2, I have a 1. So I'm going to kind of just copy those the best that I can. Again, just make sure the 1/2s are less than your 1s. And then negative 1/2. Again, they're all the same here. And then these are negative 1s. And there you go. So there's 2 slope fields down. Those are pretty easy patterns to find because there's only just one variable in each of those. But let's talk about when we have 2 variables and we kind of have to sort of find the patterns for this one. So x, y, dy, dx. So let's plug in 0, 0. When I plug in a 0, 0, my dy, dx is going to be 0. So, there we go. And then let's plug in like a 1, 0. So when I plug in a 1, 0, I'm going to get 1 minus 0, which is 1. Let's say that I do 2, 0. That's going to give me a 2. So a little bit steeper. If I were to do 3, I don't need to put in the table. It'd be even steeper than that. Okay, so I have quite a few of those down. I really haven't seen too much of a pattern except for that. Well, what about if I do negative 1? So if I do negative 1, 0, I'm going to get a negative 1. So kind of see a pattern here. It's going to get a little bit steeper than the negative side. So I did that entire row right there. Let's go ahead and do 0, 1. So I haven't had when x is 0. So if I do 0, 1, I'm also going to get negative 1. Like that. If I go higher, I'm going to get even steeper. If I make y negative, it's actually going to become positive. Okay. What 1, 1? So if I do 1, 1, 1 minus 1 is 0. Oh, okay. A little bit of a pattern here. When x and y are the same, you're going to get 0. So when x's and y's are the same, you're going to get 0. And it kind of looks like this is just going to be the same diagonally. So let's do the same thing diagonally here. And I might be able to cover everything from here. This is steep, 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 even steeper, steepest. And then you get the idea. So it looks like diagonally they're all the same. Steep, 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 pretty gosh darn steep, steep, steeper, steeper, steepest. It ain't perfect, but a grader will be able to see that and go, okay, they know what's going on. They're not going to grade your how well you draw a steep compared to other steep ones. Like between a -2 and a -3 steepness, but they can kind of see the idea here, and that is how you draw slope fields. A lot of times on AP for multiple choice, you'll be given many of these, and they'll give you choices of which one is it. So it's kind of how they ask it on AP for multiple choice. Or they could give you the equation and ask you to match up which one. For your response, they usually have you draw one of these. And then sometimes they'll ask you for a solution where you have to go ahead and draw this part right here. Just some different ways that AP asks this stuff. And that's it for the video.